Pre-engineered buildings are primarily two-dimensional structures. You have these planar frames, and the forces that are encountered are the lateral forces and the gravity forces. Gravity is snow and live and dead. So if you see, these are in two dimensions. You only see them in x and y. So in x we have wind and very negligible earthquake, which basically most of the engineers actually ignore. These are pin supported. When they are pin supported, this means that they can only resist Fy and Fx. You do not, these, since they are planar structures, they are plane frames, so there is no force that is in the z directions. That's the assumption of the design of this pre-engineered building. Now, if we look at the form, why it takes the form that it takes, you'll have to go to the bending moment diagram, and you'll see that the bending moment diagram of this building is somewhat like this. This is pin, so you have zero moment here, and it goes to the maximum value here, and then you have these values like this. So when you have this bending moment, you most probably seen that the BMD is basic dictator of the shape of the pre-engineered building, and you see pre-engineered buildings like this. So they are actual replica in the other direction of the bending moment diagram. Now, the foundation design, if you refer to the MBMA or the book of the metal building system specifications, so MBMA is the main book that defines how they work. So if I take two frames like this, so the planar direction, if this is y, this is x, and this is z, so the gravity loads and the lateral loads are resisted here by Fx and Fy, for which we have a foundation in plane direction, this and this, and for that we have this foundation. So we encounter overturning and sliding and unbalanced soil pressure. That's it. There is no need of plinth beam because there is no force in this direction. Since this is a pin connection, if there is a force that is going to be in the z direction, or we call this orthogonal force, that is resisted by the cross bracing. This, in case if this is the eaves truss, this becomes the compression flange, and in this case, if this is going like this, this becomes the tension member. So the tension is created here, compression is here, and this takes the load in the other direction. Most of the times these are pretty much negligible if you look at the wind loads being applied. So the plinth beam over here will have zero contribution in the resistance of the gravity load or the Fx and Fy. There is not such. Fz is reduced by tension compression phenomena, and it just comes here. It creates a little bit of turning, but then this beam does not do anything. You mostly use plinth beams where you need brick masonry. So if I have, let's say, this foundation here and this foundation here, and I have to have brick masonry here, let's say up till, usually we do this 3 meters. So for that purpose we use a plinth beam to support the load of this. Usually you have a spring support system here, so partial load is transferred through the deformation of this plinth beam, remaining load is transferred to this beam, and it takes the beam action happens. Since in this load case there is no masonry, so there is no need of plinth beam, to be honest. And I can show you the example on the books. If you look at the main MBMA based book, which is the metal building system specifications, you'll see that it does not have plinth beam at all discussed anywhere. However, you see this is in the direction because sometimes the Fx, The lateral load due to the wind pressure is too much that it needs to be tied, or it has to be encountered by the size. In our case, we've done that. Now, if I go to the example, you'll see this is the kind of foundation, and there is no plinth beam in this example. Even if you look at the design examples, you'll only see Fx and Fy as I just explained. See, P, which is Fy, and H is the lateral load against wind, which is horizontal load, and P is the axial load. And all the examples in all the books, you'll see that there is no discussion or mention of plinth beams. Plinth beams are only used when you want to put block masonry on.